Hi guys. So last video we went over uh, combinations of functions using operations. So operations of functions basically, and that was finding the quotient, the product, the sums of, and the differences of different functions, right? So we would have a function g, right? And we would say it's equal to something like 2x, and then we would have a function f, and we'd say it was equal to something like x, right? And we would combine these. So let's say we did g divided by f of x, right? And we were to say, and we, from last video, we know what this is. It's going to be equal to 2x divided by x, which is just equal to 2, right? And that's pretty straightforward, right? We did that last video. But, so this is operations of functions, but we don't really know what this would look like on a graph, right? I mean, sure, we could look at this too, and we could say, oh, okay, well, it's just going to be a straight line, a straight horizontal line. But we can't actually visualize the graph changing. And that can be a useful skill to have, visualizing the graph changing. So I'll show you what I mean. We're going to take both of these functions, f of x and g of x, and we're going to look at them before they were sort of combined with the other function, and an operation was performed on them, and then see how it changed. Okay? Sorry, this is an x. Looks a bit like lambda. So let's draw the graphs of both of them. Okay. So we know 2x. This is going to be g, by the way. We know 2x is going to look sort of steep, right? It's going to be sort of steep, and then f would be like just a straight diagonal line. Whoa. Well, sorry about that, but it's a straight diagonal line. Sorry about that. I'm not very good at drawing, apparently. So this is our straight diagonal line, and this is our steeper diagonal line. Okay, so that's pretty straightforward. We're able to graph these two. Now let's visualize the changes of both of them. Okay, so let's see with G. Let's look at it like this. So let's say this is your point 2, okay? So at x equals 2, what would y be? Be 4, right? Now, when we combine it with this f and we're dividing it by f, we know at every single point we're going to be dividing by whatever that x value is. So for every y, we have to divide by the x, and then that's our new y, right? So we're basically saying that our function, which normally at this point would be equal to 4, we actually have to divide that by our x value in order to get our new value. So what's 4 divided by 2? 4 divided by 2, that's 2. So we're going to have a point right here. Now let's say we go a little higher on the curve, and we go to 4. 4 and 8. Well, that's a 4 and 8. Now we're going to have to do the same thing. What's 8 divided by 4? That's a 2. So we're able to see that as this goes higher, so does the x value, and that's why we get a constant straight line. Because the bigger the y gets, sure, y is getting bigger, but so is x. So y can't increase because it's being divided by x, which is also increasing. So this is how we can see that we have a horizontal line at y is equal to 2. And that's when we do it with g. We're basically just dividing it by another function, x, right? Okay, now let's look at f. What is happening to f exactly? Well, the first thing that's happening is it's actually going to be the thing that's dividing something. So in order to get f into this, to become this function, so we have f of x equals x, we have to take the reciprocal first, and you'll see why in a second. So you have 1 over f of x equals 1 over x, right? Okay, so and then later we're going to multiply it by g of x in order to get g of x over f of x, right? Which is the same thing as this, as we discussed in the last video. Okay, so we're going to go through the S transformation on the graph as we slowly turn it first into something that's dividing. Well, we're first taking the reciprocal, and then we're going to make it so that it's dividing g of x. G, yeah. So let's take this reciprocal. Now, what does the reciprocal do exactly? Well, it will basically just say 1 divided a value at every single point. So let's see this, okay? So this was 2, and now what would y be? Well, y would be 1/2. I mean, normally it would be 2, but now that it's the reciprocal, it's going to be 1/2, okay? And what will 4 be? Well, 4 will be 1/4, because, sorry, at point 4, this is 4 too. We have to do 1 divided by x. And what's 1 divided by 4? 1/4. Okay? And we get oh, sorry, I made a mistake. See, what the graph will look like is not what I just did. Okay, sorry, let's redo that. Okay. Okay, so it will look like this. So it'll be an asymptote on the first quadrant and an asymptote on the third quadrant. And why is that? Well, we're getting lower and lower here, so it's going to be an asymptote approaching 0, right? But over here, as x approaches 0, we're basically saying 1 over x. So we're slowly dividing 1 by a lower and lower number. And as we do that, we're going to get a bigger and bigger number, right? Because the less you divide by, the bigger the number is going to be. Now the same applies here, but as you saw, I just made a mistake, but these are all negative numbers. So it'll be the same, but it will be negative, okay? So that's that. So now we have our function 1 over x. So we could see the transformation from this to this. Okay, now, what are we going to do about multiplying by g of x? This is a pretty complicated function, right? With g of x, well, we can just multiply it by g of x. It might seem a little bit daunting because of how this function looks, but it shouldn't be too difficult. So at every single point, we're just going to multiply it by 2x, okay? Now, as it gets farther and farther out, 2x is going to be bigger and bigger, right? So we're going to be multiplying it by more. And as it's lower and lower, 2x is going to be smaller and smaller. So when we multiply it by 2x like this, we're basically making this straight line, because when it's negative, let's say this part of the function, okay? And we're multiplying it by 2x. Right here at -1, we're going to be multiplying it by -2. So, and this times -2 will flip sides, and it will also double, okay? Now this over here, maybe this is -2, is going to be multiplied by -4, right? So -4 times this, it's going to flip over, and it's going to be multiplied by 4, and it's going to come here. It's going to, for every single one. Now for this one, let's say over here at 2, it's going to be multiplied by 4, so it's going to increase so that it's now at 2. Now over here, where it's actually higher than this horizontal line, 2x is going to be a decimal, so it's going to bring this down to this 2 horizontal line. So we can visualize the actual graph of these functions just by seeing it. And you can see they both ended up as g over f of x. Okay? So I'll go over that again, just in case. So we had our f of x, okay? We made it a reciprocal so that it was on the bottom, which is what we have to do. And we had to visualize what would happen if that was on a graph. And what happens is it becomes an asymptote, like this. Now this asymptote is brought back to this horizontal line when we multiply it by g of x. And this might be a little bit hard to grasp, but as this gets farther and farther out, 2x is getting smaller and smaller, right? Because x is becoming smaller and smaller as well. So 2x would be smaller and smaller. And that means that we're going to be multiplying it by a bigger negative number, which means it'll flip over first because it's a negative number, and then it will go up more. And that makes sense, right? Because the farther you go out, the lower this line is going to be. So for example, this value will be like a really, really small distance away from the x-axis. So then when you flip it, you'll need a big number to get it to 2. So it makes sense that 2x is getting bigger and bigger as you go left. Now over here, you have a really small number over here. You're going to need a big 2x. So it's good that 2x is getting bigger and bigger as it goes along this x-axis right. So then it'll bring back every single point to this 2. So right here, it's a really small number. It's going to be multiplied by negative however far away it is. So let's say this is -9 or something. Okay. First it's going to be multiplied, that it flips over, and now it's on the positive side. And then it's going to be multiplied by 9. So it's going to go back to that 9 point. It's going to go back to that horizontal axis. It's bringing back all of the points onto this horizontal axis because it gets to be a bigger and bigger number as it goes farther away, or a smaller and smaller number if it's on the negative side. So that's an example of just sort of visualizing the operations of functions. Hopefully you found that somewhat useful. Next video, we'll be going over composite functions, which are also can be viewed as similar to these, but they're not really that similar. They're very different, actually. These are operations, and next video will be composite. Thank you.